Hello, I'm Erin from CT Global Solutions, a SaaS Gold partner and reseller specializing in profitability analytics, financial management, and demand and supply planning. Welcome to our SaaS demo series, Deconstructing Demand Planning. In this video, George Haybeck, Senior Analytical Consultant at CT Global, will demonstrate SAS Visual Forecasting leveraging a retail example. From a raw Excel file to accessing the forecast, he will review how to import your data, exclude events, and select the right model for the best accuracy. Let's dive into the presentation.
Well, hello there. Good morning, good afternoon, good evening, depending on where you are. My name is George Haybeck, Senior Manager of Analytics Solutions at CT Global Solutions, a recognized SaaS Gold partner for intelligent demand planning analytics. Today, we're going to showcase visual forecasting and start from a raw Excel file within the supply chain network and go through the process of creating a project and assessing the forecast results. This is a simple retail example selling hair and skin products, and we're going to start from the file. Let's open up the file. I have highlighted certain columns of interest. We have the customer name, we have the product name, what you're actually selling on the shelf, the category where the product is sitting. Another important piece is the time period. This is monthly data, so it has January, then the February, then the March, but you can assess the aggregation or deaggregation at any level within the solution. You can go down to weekly if you wish. We have the number of shipments, which is going to be our demand, and we have the promotion, like the discount that's being offered for the product. There's other factual information in here as well. So this is the raw file we're going to bring into the solution. I have in a Google Chrome browser the SAS Intelligent Planning area, the hub, if you will. And if we go to the left, we have a analytics lifecycle component. We're going to go into the build models area to start our process. Now, the build models area allows you to build two types of statistical models. One is a time series forecasting model within visual forecasting, which is what we will do today. The other type of model is data mining and machine learning, or VDMML for short, and that will be something we can tackle on another time. So let's start. Let's click on New Project. We'll give it a name. So let's call it Forecasting Demo. Again, there's our two types. It's a forecasting project. Let's go grab that raw data we were just looking at. So I'm going to click on Import, Local File, and go grab it. Hair, skin data. We'll click Replace in case we're going to bring it in multiple times. And it gets stored in our public library here on the VIA platform. I'm going to click Import Item, and it is done, and click OK, and we'll click Save. It'll create our forecasting project now. As it creates the project, there are tabs that we will be discussing today. The first one is a very critical one. It's the Data tab that allows you to assign the layers of the data to run the forecast, but we'll also discuss the other tabs as well. Now, you notice there's a warning here. You must assign a dependent variable to run a pipeline. Well, to create a forecast, I need to know what I'm forecasting. So that's not set up here. We want to forecast shipments. So we'll choose role to be dependent. And I want to take the average forecast across my supply chain. Okay. Now, it had a variable called period, and it was the only column in Excel timestamped by month. So it automatically said, well, you must want that to be your time component. And it is month, but you can choose any aggregation level you want of your time. So month, 12 months in the year, we're set. So this is really Y equals T. Y is shipments equals our time, the basic forecast equation. Now let's talk about our hierarchy. So in our supply chain, we're going to go at the top level. We're going to do all of this at the same time, and you can choose more than one variable and assign it if it's the same role. I'm holding shift and I'm going to warehouse down to the customer name. Whoops. So let's go back and undo that. So let's do warehouse and let's go to customer name and let's go to category all the way down to the product itself on the shelf. And we're going to assign those four to be our hierarchy by the by variable. So that's our hierarchy. We're almost done. We have our Y and T and our hierarchy. Maybe I want to introduce causal factors, internal factors like discount and price. We found over industry experience that when you include causality, the forecast becomes more accurate. Now, you could have included external factors in addition, like maybe a CP index, the S&P 500, or unemployment rate, things like that. So we're all set. This is our data layer assignment, the metadata. Everything looks good. We'll move on to the pipeline. Now it creates a default pipeline for you with this family model. I'm going to delete this so we can start from scratch. The first node is our data node, which is directly stemmed from the data tab that we just had. We're going to right click and see all of the families of models in a list here. Now each one is hundreds of models possible within each family. Okay, it can go as simple as a naive model, like moving averages you can do in Excel, all the way to a neural network, which is very complex, handles nonlinearity and variable interaction. So let's go bring in maybe three for our discussion. Hierarchical forecast. Let's go bring in the neural network. Let's go bring in a seasonal model. And now we're going to go compare within each one. There's hundreds compared in here, hundreds in here, and hundreds in here. And then the optimal winner across the three of the family with a statistical measure. The default is the mean absolute percent error, or MAPE. It is weighted because we're looking at across different families of algorithms which have different parameters set up. So we want apples across apples. And we're going to use that statistic. Let's go ahead and run our pipeline. It's going to start by running the data node at the top, which now assigns all the metadata. It knows now what Y and T is, the hierarchy, etc. It's now starting with seasonal model first, multi-threading and doing all three at the same time, which is a very powerful feature on the SAS Via platform. So the seasonal is done. The next one to finish, hopefully, is now the hierarchical. Last but not least, it's doing more complex things, the neural, and it's running the comparison node now to compare, and it is done. Let's go and see what we have. We're going to see a table that looks at our weighted MAPE. Now, a best practice is, anything below 25 is considered average or good model. The lower you get to zero, the better the accuracy is, because we want the noise to be close to zero. So the neural was about less than 20. That's still very good. The hierarchical, not bad at all, still around 24. But if you notice, the seasonal model really took the cake here. Less than 4. So the seasonal is declared as the champion. Let's go and assess in a forecast viewer what the forecast at each level of the hierarchy looks like. So the first is an overall snapshot without drilling into the hierarchy. We have the green is the history, and the yellow is our future, the forecast lead out. And we went out a year, so 12 months, since it's monthly data. All right. The ranges are, the dashed line here is the mean in the history and the forecast. And then you could be 1 or 2 standard deviations, and then the range, which is the max minus the min. So the shadings tell you how far away I am from the mean. So let's expand our hierarchy. And let's pick the distribution center, 8, the warehouse. And you notice these are all of the components within DC8. Okay. Let's go down to the Publix customer. So we're getting narrower and narrower. We're selling, smaller sets of things. Publix sells these things right here. And let's go pick a certain line in the Publix, the wash line, the body wash line. All right, and there's our forecast and history there. Let's go choose this product down to this final level of the chain, the D-allo product. Now, you notice here the dots are the actual historical points, and the fitted line is the statistical fit. And it's really called a backcast since we're looking in the back in the history. Idea is if we can forecast this correctly, then the future forecast should look good. Now, a couple of hiccups here and there, but overall it's fitting the dots very well. And then our forecast picks up that maybe cycle or seasonal trend nicely. Now, maybe the analyst or planner at this level of the series, this detail, maybe wants to take the data and play with it very quickly without leaving this solution. I can click this and download the data in a CSV, open it up very quickly, and maybe do some things in Excel that I want. Maybe create a pivot table or things like that. Okay? So let's now talk about a very critical piece. Now, another aspect, remember, is I could go compare other families of models in addition by doing another pipeline and then comparing them. But we'll just stick with these 3, and then the seasonal is the winner. What about the concept of an override, a very important piece of information that a planner has to deal with? Okay. The override would be something I want to manually adjust now. Let's go use the same example. DC8, Publix was the customer. We were in the body wash line, and we chose the D-allo product. So when the planner looks at this, they might say, well, maybe for the first 5 months of the year, I want to bump up the forecast by 5% manually. Let's just say that, okay? So there's our data in a table here. I can now maybe open this calculator, and we have to give it a name. So let's call it override 1, okay? And let's go, and we want to do it for the first 5 months. And I want to bump up the forecast plus 5%. Now you could do plus 10%, whatever you want, minus. You could set it to a certain area, a value, or a range, but let's say 5%. We're going to click OK. And you notice there's our overrides now adjusted by 5% up, higher. Now let's come in here and let's submit that officially to the system. And you notice the override now has a new line. This kind of yellowish line shows our override by up 5% of our forecast. So that shows the power of doing the overriding process within visual forecasting. And last but not least, the Insights tab is a nice little book report, if you will. It shows the name of the project, how many series were here, what I was forecasting, how many pipelines I used, the winner, the winning model. I didn't use any events here, but I could have injected events if I wanted to. The statistical value, the winning MAPE, was just under 4. I could put comments in here if I was the planner, so I can get more information if I'm going to open this again. Okay. Let's take one last look, and let's just say I wanted to include certain events just to make sure we address everything. So I want to look at Christmas and let's say Mother's Day. If I add those two event variables, it says use if significant, right? And then I rerun the pipeline, it will include these, intervention events, if you will, if they're significant, and use them. Okay. I can maybe force them and make sure that they're used, so I can choose different aspects if I would like. So that concludes this demonstration for visual forecasting. My name is George Haybeck, Senior Manager, CT Global Solutions. Thank you and enjoy the rest of your day.
Thank you for watching our video in our SAS demo series, Deconstructing Demand Planning. If you would like to learn more about how analytics and CT Global can help your business, please email us at info@ctglobalsolutions.com. We would be happy to discuss demand and supply planning, provide you with a personalized demonstration, or even look at some of your sample data. We look forward to hearing from you, and thank you for watching.